In this video, we'll look at whether ClF3 is a polar or a nonpolar molecule. So we'll start with the Lewis structure here, and you'll note we have three of these fluorine atoms bonded to this central chlorine, and then we have these two lone pairs up here. So if we look at the difference in electronegativity between the fluorines and the chlorines, we'll see that fluorine, that's 3.98. This is the most electronegative element on the periodic table, but chlorine's right next to it. Still, we have a pretty big difference in electronegativity. So these bonds right here between the chlorines and the fluorines, they're going to be polar. That means the more electronegative element, in this case the fluorine, the electrons in this bond, the pair of electrons shared, they'll be around the fluorine more. Fluorine will be a little bit more negative. So each one of these bonds here, it is a polar bond. We need to look at the overall shape of the molecule, though, to figure out whether the molecule will be polar or nonpolar. Let's take a look at this in 3 dimensions. So the central atom, that'll be the chlorine. Let's add those 3 fluorine atoms, 1, 2, 3. You see they spread out to be as far away as they can from each other, but we still have the 2 lone pairs. So we add 1 lone pair, that forces everything down. We still have 1 more. We add that, and we end up with what's called a T-shaped molecular geometry. So you can see we have these 3 fluorine atoms here, and then the 2 lone pair on the top is kind of pushing everything away. So with this T-shaped molecular geometry, this molecule is asymmetrical. That means because we have an asymmetrical molecule with these fluorines all here on one side, we're going to have a polar molecule. Let's go back to our structure for ClF3. So to recap, each one of these bonds is a polar bond due to the difference in electronegativity between the fluorine and the chlorine. And then overall, because we have an asymmetrical molecule, the molecule itself will also be polar. This is Dr. B answering the question whether ClF3 is polar or nonpolar. It is polar. Thanks for watching.